I mean, that's already.
All right.
Oh. Yeah.
Good afternoon. Today we are gonna start by working on a class activity. Then we are gonna talk about motion analysis. What does it mean? What would be our approach for motion analysis? So, but before we go through that, I would like to share the suggestion that I have for you guys. So you are at the junior level. So sooner or later you are going to apply for internship or job. So you are going to be in the job market. What I'm suggesting for you guys to do is making a portfolio. Like the art students, just make a portfolio for yourself and have. You are doing so many projects and so many things while you are getting your degree. So I'm suggesting that to define some category for those projects. I have some suggestion for you, and make a copy of the project and that portfolio. Whenever you apply for a job or internship, have that portfolio on your hand, and whoever is interviewing with you, you can show him or her the project that you have done. So for example, on your CV you are saying that I know MATLAB, but whoever is hiring, who is going to hire you, he or she doesn't know how much do you know about the MATLAB, or how much would be your skill on drawing with the SolidWorks. But if they can see the project that you have done by SolidWorks or MATLAB, they have the better idea about the skills that you have for a specific topic. So for example, these are some things that it came to my mind. So for example, you can have a category programming. Inside that, make a subfolder for MATLAB. Or if you know any other language, Python or some other thing, you can make this subfolder, and inside the MATLAB, put every project that you have done by MATLAB. So in this course at least, you are gonna write 24 different codes, because from homework 3, we are gonna have some of the problems should be done by MATLAB. So put one copy on this folder. You can, for drawing, any software that you know for drawing, for example, for SolidWorks, make a copy of any project that you are done or you have drawn by SolidWorks here. If you know other toolbox or software for drawing, put the appropriate projects under this subfolder. In this class, you are supposed to design a project, and you need to draw the mechanism by SolidWorks. So this can be one of the examples for this. Design. Whatever you have done for design, for example, in this project, in this class, you are going to design a mechanism. Put it on this subfolder. Manufacturing. So one of the manufacturing is going to be additive manufacturing. An example for that is 3D printer. So you are gonna, at least for this class, you are gonna do something on this part. So you can add it on this subfolder. So these are some categories that I just talked about that for 5 minutes. So you can change that, or you can have different categories. But my point is, just collect and document any project that you are doing while you are getting your degree, and document that, categorize, and make a portfolio for yourself. So the point is, you should have a portfolio. So I just wanted to share this with you at the beginning of semester. Okay. Any question about the material? Okay, we talked about finding the minimum and maximum transmission angle for different types of the mechanism. So let's do this class activity, then we move on to the new topic, which is motion analysis. So for a 4-bar mechanism with this dimension, when I say A, I mean this link, B, C, and D. So for this mechanism, find me I work on one problem and then you work on this one. So for the given mechanism with the length of A equals to 1, B equals to 2.5, C equals to 2, and D equals to 2.5, answer the same question. Find what is the minimum and maximum transmission angle. Mu mean and mu max. The length of the mechanism are given. We are looking for minimum and maximum. The first step that you need to do is step 1. You should figure out if you have gray-shop mechanism or non-gray-shop. And if it's a gray-shop mechanism, is it crank rocker, double rocker, or double crank? So check the gray-shop criteria. So shortest link plus longest link, we are checking this. Is it greater than or less greater than or less than or equals to P plus Q? Shortest link is 1, longest link either B or D. It doesn't matter which one. So P and Q would be 2.5, Q is 2. So 1 plus 2.5, the other side 4.5. So 3.5 is less than 4.5. It's a gray-shop mechanism. This summation is less than this summation. Now, since the shortest link is adjacent to the ground, we have crank rocker. Shortest link crank rocker. So we have the crank rocker mechanism. We can use this equation to find mu mean and mu max. Cosine of mu mean, it occurs when theta equals to 0, so it's going to be B squared is the coupler. No matter how I label the links, And the equation B is the coupler. If I label this B, still this one should be used for the midterm over there. So be careful about the labeling of the mechanism. In these two examples, they are the same, but if I change the labeling, B is the coupler, C is the output, A is the input, and D is the ground. So B is the coupler, and it's 2.5 squared plus C is 2 minus A minus D. A is 1, D is 2.5. Divided by 2BC. 2 times 2.5 times 2. If I do the math and find the mu mean, I will find mu mean is 36.87. And cosine of the mu max, just change this negative to plus. This negative A minus D, the difference between these two is A minus D, A plus D. The rest would be mu max is 101.54. It occurs at theta equals to 0, it occurs at theta equals to 180. Yes?
What happens when we have a double crown? So what if I want to go in?
Yeah, that wasn't a homework.
That's a class activity that you are supposed to work on. I just changed A to 1, D to 1, so it's making double crank. Then I ask you to answer. Yes?
Can you quickly go over what you said about this that we use coupler is?
What I'm saying that in this equation we have B, C, A, and D. Right? B representing the coupler. No matter how I label the mechanism, B should be coupler, C should be output, and A is input, and D is ground. So if I change the labeling, say, all right, B, A, B, C, D. Here you should replace B by C and D by C, and A is gonna be D, and D is gonna be A. This is what I'm saying. Any question on this? I didn't do the math. So if you do the math, you find one value for cosine and mu. Do the inverse, cosine inverse, you will get this angle. Do the same thing for this. Do the cosine inverse, you will find mu max. Alright, this mechanism, I'm asking the same question, except A is 2, B is 3. I just change it a little bit to make sure that A2, B3, C is 2.5, and D equals to 1.
Question.
Yes.
Must C always be the output?
If we didn't say anything, yes, C is out. If I say the output is going to be A,
So there's no condition where we can say that either of them can be the output?
it depends on where you are going to put your driver or your motor. So the other one is going to be out.
So in this case, C is the output.
In this case, since I didn't say anything, meaning that C is the out. Number 31. Number 31, Jin Hao. What do you think? What did you do for this problem? The length of the mechanism are given. The question is, what would be the minimum and the maximum transmission angle? So let me call someone. Number 29. What kind of mechanism do we have here? Gray-Shove. And if it's Gray-Shove, what type of the Gray-Shove is that? Is it crank rocker, double crank? Double crank, because I'm checking this. Shortest link is D, so S is 1, longest link is 3. So 1 plus 3 is 4, 2 plus 2.5 is 4.5. So shortest link plus longest link is less than summation of the other two links. So it's a Gray-Shove. In Gray-Shove mechanism, shortest link is the ground. If you remember, if you have a Gray-Shove mechanism and shortest link is the ground, we are gonna have double crank. So the red and the yellow one can complete 360-degree rotation. Double crank. Did I say something else? Double crank. True? So double crank, if it's double crank, you can still use those equations that we have here. Still, minimum transmission angle, this is the transmission angle. It's occurring when theta equals to 0, and the maximum transmission angle, it's occurring when this one makes 180 degree. So if it rotates, when the red one making 0 right here. When the red one is making the 0 degree, this angle is going to be the minimum transmission angle. You can use the same equation. And when it's making just when it's at 180, this angle is 180, this angle is making the maximum transmission angle. So the same thing, just plugging the numbers there and solve for minimum and maximum transmission angle. If I change the input to this one, this angle is going to be the transmission angle. You should change these numbers corresponding. What is the A, what is the B, what is the C, and what is the D, according to the mean.
Can you go back to the slide that has like the equation on it?
Sure.
So in what way you said that the variables will change?
Let me answer his question. This a question you mean?
Yeah.
Okay. Again, we are using this equation when this one is transmission angle. If this one is transmission angle, A representing the input, B representing the coupler, C representing the output. If I move the input to this one and you are looking for this angle, then A is output, so you should replace A by C over there. C is going to be input, so you should replace C by A, and B is not going to change. This is what I'm saying. If I ask you, if I tell you the input link is going to be C, not A. Any question on this? Me? For this? I can check if you. Okay. Any question on this? Yes. It doesn't match with this. All right. Let me. Yes.
I have a question. What happens when you have one crank and one rocker or double crank, but it suffers from the point effect, which means
No,
it can go.
if these two opposed to each other. If they are if like this, see, this is the shortest link, this is the longest link. As you see, in this case, this one equals to this one equals to this. So summation of these two is going to be same as this. When it's moving, when it's at this position, when it's going to pass this one, you don't know that the entire of the mechanism going up,
Yeah.
or one of them.
The one down. Well, the thing is, there would be two different transmission angles in that case, right? Because there's two scenarios. So if there was a question like that, you would like us to find them both.
For minimum and maximum?
Yeah,
For the minimum, it's going to be C0. For the maximum, it's going to be 180. This angle is 180. For this, because everything is going to line up.
Yeah.
She's going to start.
Okay.
Make sense? Alright, you, yes.
Is it possible to have like up to 4 transmission angles?
4 transmission angle, why 4?
Because in the double rudder case.
Yes.
Double crank,
Du-
sorry.
double crank, this one and this one, you mean?
Yes.
Yep. Alright, you, okay, so, you asked about this 2.5 square. 2.5 square plus 4 minus 1 minus 2.5 square. Divided by 2 times 2.5 times 2. Okay. I'm gonna find A cosine degree of y mean 36.89. 87. Good? Alright. Any question on this? Alright, let's start motion analysis. So we are gonna start motion analysis. It's gonna take 2 or 3 weeks that we cover this one, so it's very important. Many MATLAB homeworks should be done by applying motion analysis. So after we cover this, you will learn to do the motion analysis for any given mechanism, but we start with some typical mechanism like 4-bar mechanism, slider crank mechanism. We derive the equation, then you can have practice for other types of the mechanism. So motion analysis of the mechanism. So in motion analysis, we are going to address 3 related problems. So the 3 related problems. So these are related to each other. Displacement or position analysis. Velocity analysis. And acceleration analysis. So these 3 related problems When I say related, meaning that if you want to do velocity analysis, you have to do first displacement analysis. And if you want to do acceleration analysis, you have to do first velocity analysis. So saying that, I'm going to start with displacement analysis. After we are done with this, we do velocity analysis, and then we covering acceleration analysis. So it's going to take 2 to 3 weeks that we cover all 3 problems. There are 2 approaches for motion analysis, either graphical, the second one is analytical. Graphical we covered in one class, so most of the techniques that we are using are for analytical approach. So I will start with displacement analysis. What we are going to do, what would be the objective? When one mechanism like this is a linkage mechanism, it's a 4-bar mechanism. It's you add a motor here, it's running continuously. What we want to know is what would be the location of any points. In this mechanism, when the input link is at a specific angle. So for example, I would like to know the location of any points, it can be any points in the mechanism, when the input link is at the angle of 90 degrees, or when it's at the angle of 145 degrees. This is one thing that I would like to address in displacement analysis. Find the position of all points. The second one is the orientation of all links. I have rigid body, this is rigid body, rigid body, rigid body. If you remember, rigid body can be represented by the orientation of this. One of the things that we need to locate the rigid body is the orientation. What would be the orientation of this link or this link? So when the input link at the angle of 90, what is the orientation of this? What is the orientation of the other one? When it's at a different angle, what would be the new orientation? Question? Yes.
So is the theta, is it always the shortest angle between the ground, the small angle between the ground and the crank, or is it directional?
Yeah, I will talk about how you can label the angles, but when we label the angles, it's gonna start from the ground all the way counterclockwise to the link. So if this is the input angle, this is gonna be theta, not this one, not the shortest. If you have the input angle at this position, theta is gonna define as this, because you should start from ground all the way to the input angle in counterclockwise direction. I just put in the counterclockwise. This direction is clockwise. So you shouldn't label the angle in this direction. This is one of the rules that we are following in this course. So this is what we are going to address in displacement analysis. All right. Let me talk a little bit about labeling. If you are given with a 4-bar mechanism like this, it's a 4-bar mechanism. 1, 2, 3, 4. Usually I label this as A, B, C, and D. This is the ground. So this is linked to, I start from ground, moving in the counterclockwise direction up to link 2. Then I label this angle as a theta with the index of 2, representing the angle of link 2 with the ground. So this index is representing the angle of corresponding link. So theta 2. Link 3. I draw a line at this point parallel to the ground. So ground. parallel to the ground. The angle of this link with the ground is calculated. You should start from this line, going in counterclockwise direction up to link 3, and label that as a theta 3. And for link 4, I label the angle at this point. You can label at this point as well. Just draw a line as a parallel to the ground, starting from here up to link 4. This is theta 4. Or you can draw a line at this point of link 4, starting from ground, going counterclockwise, label this one theta 4. You will see that where we need to measure the angle of theta 4 at this point, and when we are gonna measure at the other point. So it doesn't, both are correct. So you will see which one is gonna be better for the problem. Same thing for theta 3. I can draw a line parallel to the ground, define theta 3 at the other points of link 3, and say this is theta 3. So both are correct, but you should see which one is going to be better for your problem. Another thing that I would like to talk about, labeling. In many cases, instead of using A, I'm using R2. The length of this, R2. Instead of using B, I'm saying that R3, R4, and R1. Sometimes I'm using A, B, C, and D, and sometimes I'm using R1, R2, R3, and R4 to be consistent over all weekends. We have two approaches. One graphical, we draw the mechanism to scale and measure the links, angles, and the location of any point that we are looking for its position. This is what we are going to do in graphical. I will go through some examples. In analytical, it's based on vector loop equation. We set up vector loop equation and we solve the vector loop system of vector loop equation and derive the information that we desire. So we are using the vector loop equation. And this method, each link should be represented by a vector. We will go through that in just the introduction. So I treat each link as a vector, then I write the vector loop equation. By writing the vector loop equation, I will solve for displacement analysis. So if you look at this, here you can see a loop. You can start from this point, for example, OA. You can start from this point, OA, A, B, BOB, OBOA, and make a loop. So this is a loop that you make, and we write the equation for the vector loop. How we can do that, I will talk about that when we go there. So we form the closed loop. For example, for this fiber mechanism, this is the loop that we should form and write the vector loop. Here you can see one loop here you can see, and one loop you can see just going from this point, moving to this point, this point, this point, this point. And here you have three loops here. You can find another loop here. These loops are going to help out to set up the equation.
So you're saying that we can either be like where the data is or where the
Yes. What I'm saying that you can define theta 2 either at this point or at this point. If you want to define at this point, it's going to be this. Graph, go all the way to link 2. Because each link has 2 points a starting point and ending point. So the orientation of this link can be represented by any of these two. If I want to compare graphical method with analytical method in different category ease of solution, graphical approach is easier than analytical approach, but analytical approach will be more accurate than graphical. For example, you solve this displacement analysis for theta 2 equals to 60. You did the displacement analysis for theta 2 equals to 60. If you want to repeat this problem for different theta, for example, theta equals to 90, for graphical approach, you should do all the steps again. You cannot use the data that you will get from the first problem. But for analytical, once you write the code, what you need to do, just changing the input angle to 90, and it's gonna solve the problem for you. And if you compare graphical with analytical, graphical can be doable for two-dimensional. In this course, we are just covering two-dimensional. But generally speaking, analytical approach can cover for three-dimensional problems. So for that reason, we focus mainly on analytical, but we are covering graphical as well. So one part of the motion analysis is acceleration. Force is mass times acceleration. So if you find the acceleration of, for example, central gravity of link 3, by doing the acceleration analysis, you find A central gravity of link 3. Then you plug in here, you know the mass of the link, you can find the force applied to link 3, or link 2, or link 4. Also you can find the torque. Torque, we will go through that. I'm just refreshing your mind, about the dynamics. The torque applied to the rigid body is the mass moment of inertia times the angular acceleration. If you know what would be the angular acceleration of this link, theta 3, theta dot 3, theta double dot 3. Theta double dot 3 meaning alpha 3. If you know the alpha 3, if you know the information about the mass moment of inertia of link 3, you can find the torque applied to this link, or torque applied to this link. So this is how the acceleration analysis is going to help us for force analysis. We are going to do the force analysis after we are done with this. How can I do the velocity analysis? After you find the displacement equation, you differentiate with respect to time. You know that the derivative of displacement with respect to time is going to be velocity. So after you figure out the displacement equation, by differentiating that with respect to time, we can find the velocity equation. Similarly for acceleration, we differentiate velocity equation to get the acceleration equation. And graphical approach for velocity and acceleration is much more difficult than displacement. All right. Any question on this? All right. I will start with displacement analysis of the mechanism with graphical approach. The first mechanism that we are going to cover is 4-bar mechanism. This is how I label the links A, B, C, and D. Or we might see that R1, R2, R3, R4. And the way that I labeled the angle theta 2, I measure from this point, theta 3 I measure from this point, and theta 4 from this point. In all displacement analysis, I would like to see this classification, constants. Look at the terms that you will see here. Which terms are constant? Which terms are not varying with over the time? The length of the links are not changing. A, B, C, and D. A is R1, it can be R1B, R2, C, R3, and R4. And variables. Whatever is varying when mechanism is moving is variable. So first, theta 2, theta 3, and theta 4. We don't see anything else in this mechanism. Theta 2, theta 3, theta 4 are variables. And nouns. Nouns meaning that the values which are given, or we know about them. The length of the links are given, A, B, C, and D. So, if you remember, the degree of freedom for this mechanism was 1, because we have 4 links and 4 full joints. So M would be 3 times 4 minus 1 minus 2 times 4. 4 minus 1, 3. 3 times 3, 9. 9 minus 8, 1. Degree of freedom is 1, meaning that you only need one variable to be able to locate all points in the mechanism. Degree of freedom is 1. So out of these 3, if you only know the value of one of these 3, you can solve for the other 2. So theta 2 or theta 3 or theta 4 should be given, should be now. Because the degree of freedom is 1, one of them should be known, then we can solve for the other 2. So usually theta 2 is given in this type of the problem because you would like to locate the mechanism when this input link is at a specified angle, theta 2 equals to 10. So I'm just writing theta 2, but it shouldn't be necessarily theta 2. It can be theta 3 or theta 4. So we solve for unknowns. Unknowns are, we remove this from here, we are solving for the other 2, theta 3 and theta 4. Good? All right. For any displacement analysis that you are doing, I would like to see these 4 classifications. So, what are the constants, what are the variables, what are the nouns, and what are the unknowns. Let me stop here. I will work on the graphical approach of program mechanism on Wednesday. I'm posting the lecture on the canvas, so you can have access to that.